Hello students, welcome back. Let's solve exercise question number 6 of chapter 12 electricity from class 10 NCERT science textbook. And the question number 6 goes like this. A copper wire has a diameter of 0.5 millimeter and resistivity of 1.6 into 10 to the power minus 8 ohm meter. What will be the length of this wire to make its resistance 10 ohm? How much does the resistance change if the diameter is doubled? So here we have been given a copper wire whose diameter is given and its resistivity is given. We have to find out the length of this wire which will make its resistance 10 ohm. Let this be a copper wire and its diameter is given as 0.5 millimeter. Its resistivity rho is given. We have to find out what will be the length of this wire in order to make the resistance of this wire as 10 ohm. Secondly, it's asking us how much does the resistance change if the diameter is doubled. That means if we increase the diameter of the wire to double of its previous value, how does the resistance of this wire change? Alright, so let's write down first what all are given. So the diameter of this wire is given as 0.5 millimeter, which is 0.5 into 10 to the power minus 3 meter. Then we have been given the resistivity rho as 1.6 into 10 to the power minus 8 ohm meter. Thirdly, the resistance is given as 10 ohm, that is the required resistance, and we need to find out what will be the required length of this wire. The resistance is given by the formula R is equal to rho L by A. So here we have been given the resistance R, the resistivity rho, and the value of A, that is the area of cross section of the wire. We need to find out the length. So rearranging this equation, we get L is equal to R into A by rho. Now we have the resistance of this wire, we have the resistivity. First, let's find out the area of cross section of this wire. Now area formula is given by pi r square, that is pi d by 2 whole square, which is pi d square by 4. Now the value of diameter given here is 0.5 into 10 to the power minus 3 meter. So substituting these values, we get A is equal to pi, D is 0.5 into 10 to the power minus 3 whole square by 4. Now substituting the value of A in this equation, we get value of R is 10. Area of cross section we got is pi, that is 22 by 7 into 0.5 into 0.5, because it's 0.5 whole square, into 10 to the power minus 3 into 10 to the power minus 3 by 4 into the resistivity rho is given as 1.6 into 10 to the power minus 8, which is 10 into 22 by 7 into 0.5 into 0.5 is 0.25 by 4 into 1.6 into this 10 to the power minus 3, and 10 to the power minus 3 is 10 to the power minus 6 into 10 to the power minus 8. This 10 multiplied with 0.25 gives us 2.5. So it's 22 by 7 into 2.5 by 4 into 1.6 into, it comes to be 10 to the power minus 2. When this 10 to the power minus 2 goes up, it will be 10 to the power plus 2. So it's 10 to the power 2. Now we have 22 by 7 into 1 by 4 into 2.5 by 1.6 into 10 to the power plus 2. Now multiplying the numerator and denominator by 10, we get 22 by 7 into 1 by 4 into 25 by 16 into 100. So it comes to be 2 11s are 11 into 25 into 100 by 28 into 8, which is 11 into 25 is 275 by 28 into 8 is 224 into 100, which comes to be 1.227 into 100, which is 1 122.7 meter. So the length of the wire that will be needed to make its resistance of 10 ohm is 122.7 meter. So this is the correct answer. Now let's find out how much will the resistance change if its diameter is doubled. It is given that the diameter is doubled. Now the formula for resistance is given by R is equal to rho L by A, which is rho L by pi R square, which is rho L by pi d pi 2 whole square, which is rho L by pi d square by 4. So here we see that the resistance of this wire varies inversely as the square of the diameter. Now if the diameter is doubled, we get R varies inversely as 1 by 2d whole square. So R will vary inversely as 1 by 4d square. So this is the new resistance, that is the new diameter. So the resistance new will be 1 by 4 the old value, old resistance. So you can either do it in this way or you can solve it directly. That is, it's given that the new diameter is twice the old diameter. Similarly, the new radius will be equal to twice the old radius. So the new area will be pi r new square is twice the old radius. So it will be pi 2r whole square of the old radius, that is pi 4r square old. So taking this 4 out, it is pi r square old. Now this is the new area, which is 4 times the old area. So the new resistance R new will be rho L by area, which is new. So rho L by, so the new area which we got over here is 4 pi r square, that is the old radius, which is 1 by 4. Taking this 4 out, we get rho L by pi r square, that is the old radius. So r new is 1 by 4. Now rho L by pi r square is nothing but the old resistance. So it is R old. So the new resistance will be 1 by 4th of the original resistance. So the final answer is the length of the wire required is 122.7 meter, and if we double the diameter of the wire, the resistance becomes 1/4 of the old resistance. So this is the final answer. Hope you have understood the solution to this question. If this video was helpful to you, please don't forget to like this video, share it with your friends, and subscribe to the channel. It's all for in this video. See you in the next one. Please watch the playlist containing the solved physics questions and numericals from the previous year's board exams. I've shared the link of the playlist in the description box. It will be very helpful to you while preparing for your exams.